Okay, we're back to systems of equations. Like I said, I do a review and then I do a systems. Okay, these are systems of equations, but we're solving them differently. Notice we don't have to graph these. We're still finding the intersection of two lines. But we're solving the system by something called substitution. And we know what substitution is. That's why I won't be here Wednesday, where I have a substitute. So we're putting something in its place. Okay? So these are systems of equations. So I'm writing systems by substitution. Okay, so I'm going to show you, even though you have this example, I'm going to show you number 2. X equals 3y minus 1, x plus 2y equals 9. And remember, we're finding the intersection. So our goal is to find x comma y. Okay? So if we want to substitute, what do we know? If I want to substitute for either x or y, do we know something? What do we know? Do we know either x or y?
No.
Do we know what x equals?
No.
It tells us. Look at one of the equations. Do we know what x equals?
-1.
We know that x equals 3y minus 1, don't we? So in the other equation, where it would say x, write 3y minus 1 plus 2y equals 9. Because they told us what x equaled. And we know it's a system and we know they belong together. So if they say x equals this, put it into x in the other equation. Now solve the equation. Okay? So I only put the parentheses in to tell you that used to be x. That was x. It's the same thing. Does that make sense?
Yeah.
Are we good?
Yeah.
Okay. So now we have 3y minus 1 plus 2y equals 9. Can we combine like terms?
Goodness.
Yeah, so what do we have? How many y's?
2.
How many y's?
5.
5 y's. Minus 1 equals 9. Can we isolate the variable expression? And how would we do that? Get that by itself. Who's it hanging with? -1. To get rid of -1, we have to add the opposite, which is +1. And we say both sides, we need both sides of the equal sign. This is a magic road. And when we say on both sides, that's the road we're talking about. So now we have 5y equals +10. How do we get y by itself now? Divide, because we use, if this is multiplication, its inverse operation is division. So we can divide by 5, or we can multiply by the multiplicative inverse, which is its reciprocal. In this case, I like dividing. If it's a fraction, I'd rather use the multiplicative inverse. So y is equal to, what's y equal? 2. Okay? So, we've got half our answer, and it's 2. How do you think we get x? How do you think we go back and get x? Substitute into either original equation. So I think I'm going to substitute it into this one because it's going to just tell us what x is. So x equals 3 times 2 minus 1. X equals 6 minus 1. X equals 5. So our answer is 5, 2. And that's where the two lines are going to intersect, which is our goal, to find out where the two lines intersect. Using substitution, we don't graph it. We're using the substitution method. The other method was the graphing method.